Right. Well, I thought I'd start just by jumping into the to give you an idea of the scale of the problem we've got with wilding conifers. They're currently present on about 1.8 million hectares across the country. The really scary thing is, though, that at the moment they're increasing by about 6% in land area per year, and that's despite $11 million per year about being spent on control and also the development of better control tools. So it doesn't look like a battle we're actually winning at the moment. And if you extend those out, it's possible that up to 20% of the whole land area of New Zealand could be affected by wildings by 2035, by another. And that's 5.4 million hectares. I mean, these are quite sobering figures. If you go down and see the way they're spreading in parts of the country, I think they're actually reasonably believable. And that's, of course, why MPI has responded by putting some more money in, but at the moment that money is $16 million over 4 years. Well, I have to say that you could do some modelling on this, but I wouldn't have thought that that's anywhere near enough. And obviously these trees have major economic, environmental, and of course social consequences. There's a remarkable set of 3 photos there from mid-dome, just showing how rapidly Pinus contorta can fill in. But probably at least equally worrying. I'm probably going to blow something up when I do this, aren't I? So, possibly, in fact, more worrying in the long term even than this is the fact that here you've got a relatively shade-tolerant conifer, Douglas fir, which is capable of invading beech forest. So, what about biological control of wildings in New Zealand? Well, back in 2003, we held a workshop, and I can tell you that it was quite entertaining. There was unbelievably fierce opposition to any concept of introducing biocontrol agents for wildings, and being the sort of brave, fearless folk we are, we thought, we'll back off then. So we sort of parked that, and we thought, well, we didn't know the figure of 6% a year, but it was obviously carrying on. We basically thought, well, I'll be back. And sure enough, we're now back and we're promoting biocontrol of conifers, and that's what I'm going to talk about in this talk. And we've even got support, at least for some of these initiatives, from the Forest Growers Association. So things have certainly changed since 2003. And currently, there's a small biocontrol component in the MB research program, winning against wildings. And so anyway, right. Well, let's get on to so now we've kind of got the go-ahead, or at least we've no longer got fierce opposition. We still do have a problem, though, of course, because foreign conifers are worth an awful lot of money to New Zealand, approximately $5 billion a year. And the same president of the Forest Owners Association did turn around to me and say, do you know how many people's pensions are going to rely on conifers? If you mess them up, you're not going to be very popular. So obviously we would need to have agents that are highly host specific. If, for example, we're targeting non-commercial species, such as the worst one at the moment, Pinus contorta. Of course, if we were targeting the commercial species, we could promote seed or cone feeding biocontrol agents. There are a few caveats there. We'd have to make sure that they don't present a risk of, for example, either transmitting or facilitating diseases of conifers, and the one that everybody's really scared about, is pine pitch canker, which is probably going to arrive in this country at some stage because it's spreading pretty relentlessly around the globe. And certainly some of the cone feeding insects do damage to cones or leaders that will encourage pine pitch canker. However, there are others that don't. So this, for example, is the Douglas fir ghoul midge that destroys about 60% of Douglas fir seed in its native range. And we don't really see any particular reason why we shouldn't go ahead with this. However, there is a slight problem there because these little bugs are so good at destroying seed in North America that we now have a small but thriving seed export industry, which obviously isn't necessarily very compatible with introducing seed attacking agents. I put this guy in, nice weevil. It's a cone attacking weevil because the South Africans are actually working on this, but this one does facilitate potential attack by pine pitch canker, and they've got pine pitch canker in South Africa, so they haven't released this one yet, but they have done some risk assessment and they're pretty convinced that it would be safe. But we'll just watch that from the other side of the world. Now that's all I'm going to say about cone and seed attacking agents. They're likely to have a role in any overall weed biocontrol program against wildings, but I'm talking about something completely different this time. So, keeping on with the Terminator idea, well, we don't have a phased plasma rifle for these guys, I'm sorry, but we do have a new class of biocontrol agents, dwarf mistletoes. They don't sound very promising, do they? And they don't look very promising in that young infestation. But this is what they do to lodgepole pine, Pinus contorta, in the native range. They kill it. First of all, they cause extensive dieback, and then they kill it. Anyway, so just getting on to dwarf... So let's move right on to dwarf mistletoes. Well, they are the most serious, they cause the most serious diseases in a lot of conifers in North America. And I have to say, when I saw those photos of Pinus contorta, I just looked at it and went, wow, why haven't I heard of these things before? But I'm a bit focused on bugs, you see. So these things turn out to be extremely well studied. So you can go on the web and you can download this 420-page tome on dwarf mistletoes. If you want to know about host specificity of dwarf mistletoes, you turn to chapter 8. If you want to know about the natural enemies of dwarf mistletoes, you turn to chapter 12. If you want to know, anyway, it's a massive book. Turns out there are 26 species of dwarf mistletoes, and many of them are host specific to one or a few of their conifer hosts. I put in a few details here. I'll come back to why this is significant later, but they disperse by these amazing little hydrostatic seed pods. The seeds emerge out at 100 kilometers an hour, and you can hear them go pop, apparently. And they're sticky, so they then stick to, so the idea is they stick to a host. They're not bird dispersed, so they don't have fruits. They have these little exploding pods. And generally speaking, they only manage a dispersal rate of about 0.5 of a metre a year, so they're pretty slow. And once they've infected a host, it takes them 5 years to get up to flowering. So this is a pretty slow process. You're not going to wake up next week and find we've got the wildings under control. So let's specifically just go on to Pinus contorta dwarf mistletoe, and yeah, that's what it's called, which sounded very promising to me. And these quotes sounded even better. So this is a quote from David Richardson. infested stands show dramatic yield loss and substantially increased mortality rate. I thought, ooh, sounds good. And there's that photo again. They've even done studies. Now, this is actually the amount of timber. I think that's merchandisable cubic feet. It's the states, of course. And basically, over a period of 100 years, you get very little timber out of a Pinus contorta stand that's infected with dwarf mistletoes compared to a healthy stand. So again, looks pretty good. And this is another quote from the same book. Lodgepole pine that does not burn can become dominated by more shade-tolerant species as the dwarf mistletoe suppresses host growth and kills the pine. Now that reference to burning is interesting because burning does kill the dwarf mistletoe and the Pinus contorta comes back quickly. Now remember that 0.5 meters, if it's a big fire in the States, it can take centuries for the dwarf mistletoe to get back in. So that's really the dynamic you've got going in the States. And here's a little graphic I sort of stole. And so this is Pinus contorta after 20 years. So obviously with and without the mistletoe. And that's what it does after 100. And you know, you look at some of the big catchments we've got in New Zealand. If you could do that to it, okay, in 100 years, you'd still be doing very well. Obviously, it's not a quick fix, but as I sort of alluded to there, I think it's the only management tool we're likely to have unless we invent some amazing control methods for heavily infested areas. It may actually be a bit faster in New Zealand because, of course, we could help the thing disperse a bit faster than the 0.5. And also, and remember this was chapter 12 in that big tome, we know all about the enemies of the mistletoes in the States, and we would get them free of those. So they might actually go a bit faster. So, what about Pinus contorta dwarf mistletoe for New Zealand? Well, of course, there are always a few little issues. We need to check the genetics of what we've got here in terms of the tree, because actually the genetics matters in the States. So there are actually two different species of dwarf mistletoes that go for different subspecies of contorta. I think, although it has been tested against Pinus radiata, I think we would probably have to test the main provenances that we use here. A few minor bureaucratic issues. We'd have to get around that one, so we'd have to do a de-unwanting process, but it can be done. And obviously we need to do the standard hygiene things, check, we're not bringing in plant diseases, phytoplasmas, you name it. But really, apart from that, apart from all the above, just a just a little bit of research, it ought to be a relatively straightforward introduction. I mean, you just bring the seed in and you put it on plants, given, of course, those caveats above. But what about going further with dwarf mistletoes? I mean, maybe we can solve problem-dense stands of Pinus contorta, but what about Douglas fir and Pinus radiata? Because it turns out they've both got their own little private host-specific dwarf mistletoes. And the one against Douglas fir is really damaging. The one against Pinus radiata we can't tell because the plant's so rare in the native range, but it does have one. Now this seems, we did get a little bit of pushback from the forest owners with this one. It does seem completely bonkers. But remember that really slow rate of spread, 0.5 of a metre a year. If you put up a physical barrier and you have land hygiene before you plant your commercial crop, how the heck is a mistletoe that can only go up 0.5 of a metre a year going to get in before you want to harvest your crop? Now, we haven't done the modelling on this. There's and in the States, they do like to stop the mistletoes getting into natural regenerating stands and they just have a cut gap of 12 metres, and the mistletoe can't get over. So, I don't actually think it's quite as dumb as it sounds. There is a small risk of animal dispersal. The seeds do get stuck to birds in the States and can get dispersed a decent distance, but they're dioecious, so they've got male and female seed. So and they can't produce, the mistletoe can't produce seed without being pollinated. So you can see the probability of this occurring is pretty slim. And in fact, they're actually concerned about the conservation of dwarf mistletoes in the States, because if the habitat gets fragmented and you get a fire, then they gradually wink out into extinction. So they're thinking of moving them around in the States. So anyway, just going back to reality, the plan would be really to start with Pinus contorta and essentially use that as a model system once it's established and measure the dispersal and the impact, and only really consider going for the commercial species once we've got something going as a proof of concept, because we're not completely insane. But yeah, I think this has distinct possibilities. So just to summarise, dwarf mistletoes are basically a new potential set of agents for some North American wilding conifers that are here. Not all of them, they don't all have them, and once you go outside of North America, pickings get very thin indeed. So, for example, Pinus sylvestris from Europe, as far as I know, doesn't have a dwarf mistletoe. But on the positive side, I think these are potentially the only cost-effective tool we're going to have for example, where whole catchments have been invaded. I think the fact they cause long-term decline, provided you don't get fires going through, actually will probably minimise any unwanted side effects. For example, if you go in, we know if you're willing to pay the price, you can obliterate pines by aerial bombardment with off-label chemicals. But I think the side effects of that are potentially quite serious. Fire management could well be an issue. It might be something, because fire interferes with dwarf mistletoes, and also the dwarf mistletoes create a lot of dead wood. There we are. And dead wood might also encourage some pine pests, but what you can find in the literature suggests that at least bark beetles are not encouraged by invasion of the mistletoes in the States. Obviously, if there are trees you can't target, you might have to focus other management tools, strategies on those, and I imagine nip them in the bud before they get as bad as say Pinus contorta is here. So at that point, I'll stop.
Thank you.